Hello and welcome to CodeBlaze. So today we'll be implementing the greedy meshing algorithm, and this is going to be a bit longer video as I want to be as thorough as possible with the explanation. So just sit back, relax, and let's learn together. First of all, we'll get the utility methods and the existing code out of the way, and much of it you can actually copy from the existing chunk class. So for example, this constructor, this is as it is a copy paste. We are doing the same things here also, like creating the mesh object, the noise object, and basically resizing the blocks array. Now the begin play method is again pretty simple. All we need to do is call the generate blocks method. Then we generate the mesh, and finally we apply the mesh. Right. And next we can implement the generate blocks, and this again you can just copy from the existing class. Since the way we use the 2D height map doesn't change, and with this we basically fill in the blocks array depending upon the height map value. We either set it to a stone block or an air block. And the next existing method would be apply mesh, and this also you can copy from the existing code. The only difference here is now we are using the mesh data variable. So rather than passing the triangles and the vertex arrays directly, since we would be populating these in the mesh data variable, that is the struct we created in the previous video. So we'll be using that to pass in the vertex data or the mesh data to create mesh section. So with this, we have our most of the existing code copied over. We just need to implement a few utility methods. So let's get started with that. So the first utility method we'll implement is get block index. This is again the flattening method we have to convert three-dimensional indexes to one-dimensional index for the blocks array. So again, you can just copy it over. Then we have this get block. This is a new utility method that we have added, but this is also pretty simple. All we do is we first check for the bounds. So if any of the component of the index is greater than the size, we return the air block. Or if it's lower than 0, we return an air block. If that's not the case, we query the blocks array using the get block index. Okay, so using this method, we would ideally get the correct block wherever required. Now, if you're building a proper system, in the cases of this bounds check, you would ideally want to check the neighboring chunks and return blocks from that chunks. That way you can have faces culled between the chunks also. And finally, we need to implement compare mask, and this is pretty simple. So we just take m1 dot block equal to m2 dot block and m1 dot normal equal to m2 dot normal. So we are basically comparing two mask values and returning a Boolean result. So we have all our utility methods done. The only thing now left would be the generate mesh and create quad. And generate mesh is where the bulk of our greedy meshing algorithm will exist, and create quad will be internally called to actually fill in the mesh data arrays. So let's get started with that now. So the first thing we need to do in greedy meshing is actually iterate over all the three axes, since we'll be generating slices in all three directions. Now to do that, I'll just have a simple for loop. I'll call this axis, and this will run till 3. So that will represent the X, Y, and Z axis, right? So just to be clear about what I mean when I say a slice, I created this simple illustration in Blender. So imagine we are iterating along the x-axis, then a slice would be a perpendicular plane along the YZ axis, right? Now each of these slices are going to be on integral intervals. So that would be the distance of a block. And each of this slice would, or it may or may not contribute to the final mesh. So there could be slices without any faces, or there could be slices with just a single face or a multiple face, right? Or the whole thing could be a face. That depends upon the height map values, right? So all you need to understand here is that slices are nothing just planes. perpendicular to the current axis direction. So back in our for loop, now we'll define some variables which are going to be used throughout the 3D meshing stuff. So first would be the reference to the perpendicular axis, so that we can store in constant axis 1. So axis 1 would be nothing but axis plus 1 mod 3, right? So if the current axis is axis 0, this would return the value of 1, and that way we'll be getting the reference to the one of the perpendicular axis. And similarly, we'll have axis 2 also. So this way we know the other two axes for the current axis, right? Next, we'll store the limits along each axis. So that is basically the x, y, and z components of the size variable that we have. So I'll have constant main axis limit, and this we can get from the size variable. Now these vector variables can be accessed like from an array like syntax. So if I put this index axis and if I give a value of 0, that would be the x component. But here we want the value of the main axis, so we just pass in this variable. So depending upon the axis value, we'll get the limit across that main axis. Similarly, we'll store the limit for axis 1 and axis 2 also. Axis 1 limit, so this would be size axis 1, and I'll duplicate this line. So this would be axis 2 limit, right? uh, 2. I'll change this to so 2. So these limits will be used in our internal for loops, basically till when we want to iterate. Okay. Next, we'll have two more integer vectors. So this would be delta axis 1. This would be nothing but an f int vector 0. So we'll initialize this to the 0 value, and similarly we'll have delta axis 2. Now I'll explain the use of these variables later when they come into point, but for now you can basically take them as the growth in the particular direction when we start merging the faces. So they will in the end represent the width and the height of a given face, right? Next, we will store another int vector. This would be the chunk iteration. I just call it chunk idea. So this will represent the blocks that we are iterating through. So on all places, we'll basically be flattening this specific vector to get the correct block. So we can again initialize this to the 0 value. Finally, we need an axis mask, right? And again, I'll initialize this to an 0 value. F int vector 0 value. So this mask would represent which axis is active. So on one of its components, the x, y, and z component, one of the value would be 1. So if the main axis we are iterating over the x-axis, this vector would be 1, 0, 0. So again, this vector would be useful ahead. So it's better to store it or initialize it here only, right? And as I said, it should represent the value of 1 depending upon which axis we are iterating over. So we'll set that using axis mask, and I'll say axis equal to 1. I notice I have a spelling mistake here. Yep, that's fine. Don't know what I'm thinking about. Yeah, but now we'll continue. So finally, now the last thing we need to declare is our mask. So as I said earlier, for each slice, we will be creating a mask, and that we would be storing in a T array. So a T array of type f mask. Now f mask is a struct that we declared in our class in the previous video. So that is what we want. And I'll just call this mask, and we can resize this array since we know the size of the mask, and that would be the axis limits of the perpendicular axis. So I'll just call the set num and I'll pass in access 1 limit into access 2 limit. So again, this would be a 2-dimensional array that we are flattening down to 1 dimension, right? And why the size would be access 1 and access 2 limits? So that is pretty much visible from the earlier Blender illustration that I showed. So that would be the dimensions of the plane or the slice, right? So with this, we have all our variables that we will be requiring throughout the 3D meshing algorithms defined. And next, we are going to start with creating the mask for each slice. So now we'll be start by iterating along the main axis for each slice basically. So I'll just put a comment here, check each slice. And this we will do with again a for loop. So I'll have a for loop here. And this time we will be using the chunk iteration variable. So we know that we are going to be iterating over the main axis. And by storing this iteration values in the chunk iteration variable, it will be easier for us to access the blocks when required, right? So in the chunk iteration, using the array accessor syntax, we'll say for the main axis, you start with -1. Again, I'll explain why we need -1 here. Then you go till chunk iteration along this axis is less than the main axis limit. Okay. And finally, we won't be giving any increment condition here since we'll be doing that manually ahead. So you can just leave this part empty in the for loop and we'll just open the brackets. So the first thing that we define here is another variable. We'll just call it n and this would be 0. So n will basically represent the index inside the mask. And again, this would require some flattening, but since it's a 2-dimensional array, we don't need to deal with it much, right? So now I'll explain how we'll go about using the mask. So back to this Blender illustration, if you consider a chunk which has size of 3 along x-axis, as you can see, we can have 3 blocks here between these slices. So the number of slices required in that case would be 4 to cover up the whole mesh. So in general, you can say that the number of slices required is 1 plus the size along that direction, right? And with those slices, you'll be able to wrap or basically cover up the whole mesh. Now, if we start the iteration through -1, we can call this slice as slice -1. Then the block in this space would be block 0. This would be slice 0, then the block 1, slice 1, block 2, and finally the slice 2. And with that, we'll have all the slices covered and the mesh generated. Now for each slice, we'll be creating a mask, and mask is nothing but a array, and each value in that array would represent the block type and normal direction. Now to create the mask, we need to iterate over the perpendicular directions. So basically we'll have two nested for loops here. Again, so this would be a for loop, and this also will use the chunk iteration, but this time we'll go along the axis 2. So for axis 2 equal to 0 and chunk iteration along axis 2 should be less than the axis 2 limit. And finally, we can say plus plus chunk iteration along axis 2, right? So this would be our first loop. And similarly, I can just copy this since we need to do the same along axis 1. And with these two for loops, we are basically iterating along the perpendicular axis. So I'll change this to axis 1 limit, right? Then again, we'll open the bracket. So now that we are iterating along the perpendicular axis, we need to get the current block here. So I'll just call const auto current block. And this would be equal to, so here we'll use the get block utility method. So we'll get the bounds check also to get block, and we'll be directly passing the chunk iteration. So this will give us the current block. And finally, we need a block along which we need to compare the current block to, so that we can get from const auto compare block. So this would be get block. This would be chunk iteration chunk ITR plus the access mask. Now by adding the access mask, we'll be getting the adjacent or the neighboring block in that particular direction, or the direction along which we are iterating through the main axis. Now we'll store the transparency result of these two blocks in some bools. So const bool current block opaque. So this would nothing be, but we'll just compare the current block value to the air block value. So we'll take the current block not equal to air e block air. So if this is the case, then the current block is an opaque block, and similarly we need to do the same for the compare block. Right, and now depending upon these Boolean values, we'll be filling in the mask. Now to explain that filling conditions, I'll again go back to the Blender illustration. So just hang in there. So back here in Blender, if we consider this block to be the current block, and if we are iterating along the x-axis, so when we add the access mask, we'll basically be getting this block here. And then we will be storing the transparency values of both the blocks. Now there can be 4 conditions possible here. If the first would be if both these blocks are opaque blocks or stone blocks, in that case we don't need to do anything since the face here in between won't be visible. And similarly, if both these blocks are transparent blocks or the air blocks, in that case also we don't need to do anything. Now if this block here is an opaque block, but the block here is a transparent block, in that case we need to create a face here that faces towards the compare block direction, and vice versa is true. So if this block here is an opaque block but this block here is a transparent block, then we need to create a face that has a normal direction towards the current block. So this is how we'll basically be filling our mask here. And again, by seeing the code, it will be more clear. So back in our code, I'll put an if condition here, and I'll say if the current block opaque is equal to the compare block opaque. So this will take care of both cases when both are true and when both are false. So in that case, we'll fill in the mask here. Mask and as I said before, n is the index through which we are iterating through the mask, and we can just say n plus plus. So the value 0 will come and then n will increment, and I can say this would be f mask. And for the block type, I can just give it the null block since we had that defined in our enum. So anyway, this is not going to be used, and the normal direction would be 0 because we just don't want to show or create a face here. So again, now we will do an else condition here. Else if the current block is opaque, right? But the compare block is not opaque. In this case, again, we'll fill in the mask here with n plus plus. This would be f mask. F mask, right? And the block type would be the current block type. So this would be current block here. Since we are going to create a face according to the current block, since that's the opaque one. And for this, we'll say a normal direction of 1. So basically, if we are creating a face towards the direction of the compare block, we say the normal direction is 1. And in the else case here, else would basically be when the compare block is opaque, since that's the only case remaining. Here again, we'll fill in the mask with n++, and this time the block type would be compare block, and the normal value would be -1. So this value of 1 and -1 is basically for our own representation. You could use some other complementary values here if you want, right? And I'll just put a comma here, right? So basically with these two for loops, we have filled the mask for the current slice. Now we'll need to use this mask value to create the faces or the quads. And to do that, I'll do some preparation here. So now we can safely increment the chunk iteration along the main axis. If you remember, we weren't doing this here in the main loop. You could move there also, like with some refactoring. I think it should be possible there, but this is how I implemented it. And since we will need to iterate through the mask again to create the quads, I'll set the mask iteration back to 0. And I'm pretty sure I could have given it a better name other than n, but yeah, you could call it mask iteration. So the next step that we are going to do is generate mesh from the mask. Okay, so that's the last thing that we need to do, and after that we'll have our algorithm complete. So to generate mesh, again we need to iterate over the whole mask, and to do that we'll have two nested for loops. Int j equal to 0, j less than its 2 limit, and plus j. Similarly, we'll have another for loop here for I equal to 0 less than axis 1 limit. And for this internal for loop, we don't need the increment statement here. We'll be controlling it manually inside the loop. The first thing you need to do is check if the current mask value, mask n, has a normal value of not equal to 0. Since we need to create face only when the normal value is not equal to 0, again, normal value of 0 represents if both the blocks are transparent or opaque. So by doing this, we will be creating quads only when required, right? So we'll store the current mask value in a variable. I'll just call it const.auto current mask. This would be equal to mask n. Again, n is something that we need to iterate or increment inside our loops, otherwise we won't see any effect. And we'll apply the I and j values of these loops back to the chunk iteration. So now inside these loops, this chunk iteration will ultimately represent the vertex coordinates for the quad, which you'll see ahead how that happens. But for now, you can just say chunk iteration axis 1 equal to I, since that is the thing iterating over the axis 1, and axis 2 equal to j. And then we'll define a variable here called int width. So this will represent the width of the current quad or how large it can grow. The next step is basically merging of the faces or the mask values that have the same value. So to find out the width of a current quad, we basically need to expand along the axis 1, and in each step we just need to compare the mask values. If they are same, we can safely expand. If they are different, we break at that position and we note the maximum possible width for that given face. So to do that, we'll just have a for loop here with width equal to 1, since 1 would be the smallest size of the face. Then we should have I plus width less than axis 1 limit, since we don't want to go outside the limits or the outside the chunk. Our faces should be inside the chunk. And along with this condition, we need to make sure the mask value is same. So we'll call the compare mask function here, compare mask function, and to it we would pass the current mask value to which we are iterating. So that would be mask n plus the width, and the second mask value would be the current mask, right? And finally we can say plus plus width. And this, there wouldn't be any body in this for loop since we don't need to do anything. All our logic is happening here only. So till the mask values are same, the width will keep on expanding, and as soon as we have something with a different mask value or we hit the limit of the chunk, this for loop will finish, and at the end of this for loop we'll have the width of the quad, or the maximum size the quad can expand. And similarly we need to do for the height also. In height, but the way we are going to do for height is we are going to compare the mask values alongside the width. So first we'll expand in axis 1, then we'll check in axis 2 on how far we can go. So to do this we'll need two for loops, basically nested loops, and I'll store a boolean flag also here, bool done. I'll initialize this to false, right? So the first for loop that we are going to have is on height, height equal to 1. Again, that is the smallest size of the face. J plus height should be less than axis 2 limit, and plus plus height. Now, the reason we need a nested for loop, because we need to compare the mask values along each of the width on how long we have expanded. So again, if I show it in Blender, suppose for this face, we have expanded till here. Now we are going to start expanding along the height. So we need to compare all these four blocks. So till all these four blocks also have the same value. Okay, now we can have this quad. Now if we expand more, but this block has a different value. So we can't have an height of 3. So our height would be 2 and width would be 4. And that is how we'll get those bigger faces, and we would basically be merging them. So back again here, we'll have another loop for I, and this we can call k. So k would go till width only. So we already know the value of width. And again, we'll compare here. So if compare mask, so the current mask value would be mask n plus k, like how much width we have gone, plus the height into the axis 1 limit. Now, the reason we need to multiply this is since we are kind of inputting a two-dimensional array index along the width and height, so we just need to flatten it down. So if we take this mask value and compare it to the current mask, and till this is same, we can continue. Okay. Now, if this is not same, we just set the done variable to false and break the inner loop, right? And in the outer loop, we'll check if done, we break the outer loop also. This basically means that if at any point we get a mask value which is not comparable or not same to the current mask, we break it out. And after these two for loops, we have the width and height of the maximum possible quad using the current mask value. So all we need to do is store these values in the delta variables. So that will make it easier to do vector addition to find out the coordinates. So I'll say delta axis 1 equal to width, and delta axis 2 equal to height, right? So all now we need to do is create the quad and clear out the mask values that have already been used. So just hang on for a bit more and we'll finally have greedy meshing done. Now we can call the create quad method, though we haven't implemented it, but we'll do that later on. So we'll call the create quad method. The first thing we need to pass in is the mask value. That would be current mask. Then we need to pass in the axis mask. And finally, 4 vectors representing the vertex positions of the quad. And the way we are going to do that is the first vertex position would basically be chunk ITR. As I said, once we set the ij values to the chunk ITR variable, this will represent the first vertex coordinate, right? And the second coordinate here would be chunk ITR going to show now. Yeah, chunk ITR plus delta axis 1. So we are basically adding the width to the previous coordinate. Similarly, we'll do chunk ITR plus delta axis 2. So in this case, we have added the height, and the final coordinate would be chunk ITR plus delta axis 1 and plus delta axis 2. So again, this could be explained here in Blender. So chunk ITR would represent this vertex here. Once we add the width, we get this vertex, and for the third vertex, we had the height. So we have this vertex here, and when we add both of them, we finally get this fourth final vertex. And with this, we can create our quad. So all we need to do is implement this create quad and fill in the mesh data. Now, before that, I want to complete this function here or generate mesh. So after creating the quad, we now just need to do some cleanup. So I can set the delta axis 1 variable back to f 0 value. So f int vector 0 value. Similarly, we'll set the delta axis 2 to also 0. So we are basically resetting this. And if possible, you can actually get rid of these variables if you refactor it in such a way and directly create your vectors here. And finally, we need to do is clear off the mask values. So since we are iterating outside the current scope, like when we do the growth, we need to set the mask values that have already been consumed. So for that, we'll have a nested for loop. I'll just copy it over and explain it. Right. This will go in height and width. So using the height and width, we'll set these mask values to null. So that would basically mean these masks have already been considered for creating quads. So next time when we iterate over, we'll have the normal value as 0. So the function won't do anything. And finally, the most important part, we actually need to increment the I value and the n value. And that is again pretty simple. So I can be incremented by the width, and that is the amount of values that we have considered across the axis 1, and n will also be incremented by width, since that's the number of masks we have already considered. Now we have considered more masks than these, like the height masks also, but those will be covered by setting these to 0. So while iterating, the values that have already been considered during the height growth will come. So those will have normal 0, so it won't do anything. So this will again be width. And similarly, in the else condition for this upper if, we'll increment I and n by 1. So else I plus plus and n plus plus, right? So with this, we have completed our generate mesh method. So that is all there is for the greedy meshing algorithm. So only thing we need to do is implement this create quad method. we basically use these vertex values to fill in the mesh data. That's the last thing we do before compiling and testing. So just hang on for like few more minutes. I know this has been dragging along, but I want to be as thorough as possible. So in create quad, the first thing we can do is compute the normal vector for the given quad, and that I'll just store here const auto normal, and this would basically be an f vector of axis mask into the mask dot normal, right? So this would be a vector along the axis, so either one of the values would be 1 x, y, or z, and that would be multiplied by mask dot normal, so it would be either +1 or -1, right? Next we need to add the vertex array vertex data, so I'll just copy this. So we basically call vertices dot add 4 times for all these 4 vertices, and we multiply them by 100 to scale it according to the Unreal Engine's coordinates. Next, we need to add the triangle data. This again, I'll copy. Now, there is a trick that I'm using here. So basically, the orientation or the order of our triangles should match the normal value. And we can get the triangle values using the vertex count. I have explained this previously also. Now, to make the correct orientation come out, we basically use the normal value. So if you put in some example values here, so let's assume the vertex count is 0 and the normal value is 1. So we'll basically be adding 0, 3, 2, then this would be 3, 0, and this would be 2, right? So if you just iterate or basically put in some example values, you'll see how according to the right hand thumb rule or the left hand, like depending upon the coordinate system, this will give the correct orientation of the triangles. So again, I'll link down the anatomy of the cube video before, because that explains it in a much better way than I can ever. So yeah, with these things, you'll get the correct triangle value. So you can just copy this if you want. And next we'll add the UV values. So I'll set the UV values in the 0 channel, and I'm deliberately not scaling these UV values since I want to see the UV stretched out, as I want to visualize the faces being merged. But ideally you will multiply these ones with width and the height, so you'll need to pass in the width and the height also that we have computed here. And basically wherever there's a 1 here in x-axis we pass in the width, and where there is 1 here in y-axis we pass in the height. So this is something I believe you can do it on your own, and maybe I'll show it when we actually do some textures here. Finally, we need to add the normal that we computed above, and this is just the same value being added 4 times for each vertex. And the next thing we need to do is increment the vertex count. Okay, vertex count by 4. So with this, we have all of our implementation part done. So I'm just now going to try it out. There could be any mistakes I have made, and maybe you may have already identified those mistakes. So let's just hope for the best that this works. Otherwise, we'll have some kind of a bug fixing session after this, right? So let's see the result now. Now, if you have been exactly following my code, you may be getting some weird results, since I'm getting that. Since I've just changed the chunk world to spawn my greedy chunks, and if I play, I get these weird faces going to the sky. And well, we all are humans and we make some silly mistakes. And the reason for this is, if we go back to our code and we see the breaking of our height, I had set done to false, which it should be true. So with this simple change, if I go ahead and recompile, you will get everything working correctly. Even I was, well, even I didn't have complete faith in myself that the first time implementation would go correct. But yeah, these kind of mistakes happens. Uh, but debugging this could be a nightmare since it's a small change. Figure out why it isn't working. Luckily for me, I had implemented this before, so I could just compare it with that. But if you have already spotted this mistake, good for you. I guess you are more attentive than me. So now that we have fixed that, and if I play it, we get our proper greedy chunks. And since we don't have, we are not scaling our UV values, you can see the grid pattern that Unreal has in the default material stretching out. And that clearly shows the bigger faces that we are creating. Again, you can just go into the wireframe mode, and I'll come out of this and I'll hide the sky dome thing that called the sky sphere. Now we can just see the wireframe view of our basically chunks, and you can clearly see the bigger faces. Now, one thing to note is we are not using the most optimal growth algorithm, since we are always checking along the width first and then the height. So this is not the most optimal result, but it's good enough and it's simple enough, and you'll definitely gain a huge amount of boost in performance, since your vertex count should be around 10% of the original. So as I showed earlier in my previous chunk class, I was having around 20,000 vertices. With greedy meshing, it comes down to around 2,000. So that's it for greedy meshing and for this episode also. I know it has been a quite a long episode. And in the next episodes, I'm going to show you a new meshing algorithm called marching cubes. With that, you'll be able to create some smooth terrains. So that episode may take a while to create. Marching cube is something I need to implement myself first. Not that well versed with it, but I'll definitely get that out. Uh, not totally not knowing about that. So subscribe for the upcoming content. If you have any suggestions or feedback, leave them down below in the comments, and leave a rating and maybe share with your friend. It helps the channel grow. So thank you.